All right, now I'm going to give some hints for 3 exercises from section 10.2. First one is exercise 10.2.3. Now we had theorem 10.2.1, which talks about left cosets. And in this exercise, you're supposed to think about what the conditions would be for right cosets. Some of them are pretty easy. I think the hard one may be number 2. But for number 2, you need to think that every multiplication operation should be written in reverse order. Okay, so you have a multiplication operation there, and if you're replacing left cosets with right cosets, you're basically exchanging left multiplication with right multiplication. So you should think of anytime you see a multiplication operation, you should reverse the order of the operands. Right? So that may help you figure out how to do part 2 here and find the equivalent condition for right cosets. Now 10.2.5 says I want to prove that the union of all cosets of a subgroup H in a big group G is equal to big G. Now again, when we want to show 2 sets are equal, usually there are 2 parts. One is you show that the set on the left is included in the set on the right, and then we also want to show vice versa. And the proof is element by element. So first of all, every element of the set on the left has the form G times H, where G is in big G and H is in big H. To show that the left-hand set is included in G, all you need to do is show that this element is in big G. Right? Because every element has that form. If every element is in big G, then the whole set is contained in big G. Now, for part B, you want to do something similar. Given any element big G, you need to show there exists a left coset of H that contains little g. This implies that little g is contained in the union of left cosets, right? So I just need to show every element here is contained in at least one of the sets over here. All right, so that's how you show this set equality, by proving inclusion both ways. All right, now here's another exercise, 10.2.14. It says consider the left cosets of SL2 of R. This is the 2 by 2 matrices with determinant 1. And GL2 of R, this is the 2 by 2 matrices with determinant non-zero or invertible 2 by 2 matrices. And they show that 2 matrices in GL2R are in the same left coset of SL2 of R, if and only if they have the same determinant. Now, is the same true for right cosets? Prove your answer. All right, so we want to show that 2 elements in the same coset of SL2 of R must have the same determinant, and vice versa. You'll need these 2 facts. First of all, you'll need the fact that the determinant of the product of 2 matrices is the product of the determinants. Determinant of AB equals determinant of A times determinant of B. And the second fact you'll need is that determinant of A inverse is 1 over the determinant of A. In fact, part B follows from part A because A times A inverse is the identity. So you can think about that. So that's one part that you'll need. Another part that you'll need is the equivalence of 2 and 3 in proposition 10.2.1. So let's go back and see what that is. So you'll have these 2 equivalences. G1 inverse G2 is in H is the same thing as saying that G2 is in the coset determined by G1. So you can use that fact also, because if you have 2 matrices with the same determinant, and you take, if you have A and B have the same determinant, and then you take AB inverse, you can figure out what the determinant of AB inverse is. All right, so that's all I'm going to say about that. And you can do those problems, and hopefully that will help you understand this.